So the second step of the Jacobi iteration is trying to convert the current equations, the isolated x, y, z, into an iteration form. So the second step of Jacobi iteration is trying to rewrite the XYZ form with iteration component. Okay, iteration component. Then how we write? So x k plus 1 means the next iteration will be equal to the current iteration yk minus zk plus 7 divided by 4. And we can also write into simplified form, which is 1 over 4 by k minus 1 over 4 zk plus 7 over 4. Then yk plus 1 equals to minus 4xk minus zk minus 21 divided by minus 8. And that will be 1 over 2xk plus 1 over 8zk plus 21 divided by 8. You can also write zk plus 1 equals to 2xk minus yk plus 15 divided by 5. And that is 2 over 5xk minus 1 over 5yk plus 3. Okay, so this is a new form for xyz, but in an iteration format. And what you can do is you can say this is the iteration step, which is k plus 1 step. And this is your current step, which is the current k step. So you can use in a loop, or you can use to looping out the current value with the iteration k plus 1 x value. Then what we are trying to do for the Jacobi iteration is that the Jacobi iteration will look like this. You gave an initial guess, which is x1, y1, z1. So that is your initial guess. Then based on whatever the iteration loop generated, you can generate x2, y2, z2. And you can keep generating until the step. So you can have k step or k plus 1 step until the n step, xn, yn, zn. And what you are going to compare, you compare the next step and the current step, and you can see the difference. When their difference is close enough, that means they are trying to get to the true values. So they are going to close to true value. And in that sense, you set up the tolerance, you can stop whenever the difference is smaller than the tolerance. Okay, so that is how the Jacobi iteration works. But you need to give a starter, which is the initial guess. Then it's run the loop until the difference between the current and the previous one are smaller than the tolerance you set up, is close to the true value. Okay, so what we can use the MATLAB to do is that we can compare the true value, and we can compare using the Jacobi iteration how the things look like. So for the Jacobi iteration, we have our Jacobi matrices, which is for the looping. So the Jacobi iterative matrices, which is xk plus 1, can be represent xk plus 1 equals to xk plus axk plus b. Okay, and this xk plus 1 is this column, xk plus 1, yk plus 1, zk plus 1. This xk means xk, yk, zk. The is the coefficients related to that. The B will be this part. So we can write our Jacobi iterations for this problem, this 3x3 system. So the A, we can say A mu, which is the Jacobi iterative matrices, will be 0, 1/4, minus 1/4. The second row will be 1/2, 0, 1/8. The third one will be 2/5, minus 1/5 and 0. The B will be equals to 7/4, 21/8, 3. Okay. So this is our A matrices, B matrices, and the looping is times whatever the starter going to the next value. Then update the next value with the current xk plus 1 and run the loop until your difference between the current and the previous one is smaller than the tolerance you are done. And for this problem side, the exact solution, we will show in my lab will be equals to xyz is 2, 4, 3. And we will show in my lab how we use the Jacobi iterations to run the loop. Okay.